Hi developmental math students, and this is going to be your review video for the final. We've made it to the end of this class, so this is the last video I have for you. In this video, we're going to look at 5 questions. They're going to come from the 4 units we've looked at in this class, and they're really going to emphasize on the homework questions or test questions that it looks like the most students struggled with. That way we're getting one last look at these type of questions to help you guys prepare better for the final. So to begin, we've got this first question, which is going to be focusing on integers. One of the most important things you'll need to know in order to be successful in the next math class is how you do math with negative numbers or integers. So in this question, it says, order these expressions from least to greatest. There are 4 different problems here, and we want to organize them from least, for the smallest, to the greatest. I'm going to call this number 1, number 2, number 3, and number 4. That way you don't have to write them all out. Just put these numbers 1, 2, 3, 4 in order from least to greatest. Go ahead and try that now. All right. Well, in order to do this, hopefully you started off by figuring out what each of these equals. We need to know what the answer is. That way we can organize those answers from smallest to biggest. This first one here says 4 minus negative 3. One of the things we need to know if we want to be experts on integers is what you do right here. If you've got those 2 negative signs like that, one way you can think of it is a negative times a negative gives you a positive. Or you can think of it as subtracting a negative is the same thing as adding. Either way, that's going to be 4 plus 3. Not 4 plus negative 3, just 4 plus 3. Those 2 negatives right there change that 3 into a positive. Once you have 4 plus 3, it makes it a lot easier to say, okay, that first one equals 7, a positive 7. This next one says negative 6.1 plus 2. So again, I'm checking to see, can you do math with negatives? I've also thrown in a decimal there. For this one of the first questions you should be asking yourself is, what do I want to do with those numbers? Because they are different signs, because we have a negative and a positive, that tells me I want to subtract. So I'm going to want to write my 6.1, and then I want to subtract a 2. Now when it comes to subtracting that 2, you want to be careful. That 2 is a whole number, so I need to subtract the 2 here and then change it to 2.0. When I go to subtract, I'll get 4.1. The last thing I need to do, don't forget this part, is check the sign. Should that 4.1 be positive or negative? Well, if I come back to this original problem here, that 6.1 is larger. It's a negative number, so my answer would be negative. This second one here equals negative 4.1, and that first one was 7. This next one here, I've got 8 right next to a parentheses, and then in parentheses, I've got negative 7.3. One of the things I'm checking here is see, do you remember what type of math this is? Well, if you've got a number right next to parentheses, that's a multiplication problem. So this says 8 times negative 7.3. I'm going to want to multiply. It does not matter the order you write that multiplication. I like to write the longer number on top. So I'm going to write that 7.3 on top and then times 8. You can write that negative sign there if you want. In this first part though, I'm just really focusing on what we get when we multiply those numbers. When I go to multiply, I'll say 8 times 3. Well, 8 times 3 is 8 plus 8 plus 8, that's 24. So I'll write my 4 here and carry my 2. Then I'll do 8 times 7. That is 56 plus our 2, 56, 57, 58. That gives me 58 that I'm going to write down here. Now the last part of this is, where does that decimal go? This was a decimal, so I need a decimal somewhere in my answer. When you're talking about adding or subtracting decimals, that decimal point just comes straight down. When you're talking about multiplying decimals, notice that my decimal points don't line up. They don't need to line up with multiplication. And then for multiplying decimals, what you do is you count how many numbers are behind your decimal point. So in this problem here, I've got 1 number behind my decimal point. There's no numbers here behind a decimal point, so there's a total of 1 digit behind a decimal point in the problem. Means in my answer I need 1 number after the decimal point. So here I'm just going to go back 1, and I get 58.4. Just some quick practice. If that had been 7.3 times 0.8, then there would have been 2 numbers behind my decimal point. So I would have needed to go 1, 2, and put the decimal there so that there's 2 numbers behind the decimal point. That wasn't the problem though. So we're left with 58.4. Last step, are you checking your sign? Well, I'm multiplying different signs. I've got a positive and a negative, and when those signs are different, always, 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 the answer is negative. Here, if you have different signs, the answer is always negative. It is only for adding and subtracting problems where you're looking at the sign of the bigger number. That's an important difference between adding and subtracting and multiplying and dividing. So for this one, we get negative 58.4. I've got one last one to do. I've got negative 100, and then that like slash or that fraction line, negative 10. One of the things I'm checking on this problem is, do you remember what that line there means? That is a division line. So this is really saying negative 100 divided by negative 10. If I wanted to divide that, the first thing I would do is 100 divided by 10. You can ask yourself how many 10s go into 100 or how many 10s you need to make 100. The answer for that would be 10. And then I am dividing and my signs are the same. If you are multiplying or dividing and the signs are the same, your answer is positive. So this right here would be a positive 10. Now that I've got all 4 answers, my last step is now I can order these from least to greatest. So looking through these, which is the smallest? Well, right away, I see there's 2 negative numbers. Negative numbers are always, always, always smaller than positive numbers. So these 2 numbers here should be our first and our second one. Now the smallest number is negative 58.4. This one right here would come first. Sometimes that's confusing to students because we know 4 is smaller than 58. So why is negative 58 smaller than negative 4? I think the easiest one to think of is think of it in real life with like temperature or money. If these are bank accounts, this is less money than negative $4, right? Negative 58 is you owe $58. Here you only owe 4. Temperature, the same idea. This is a lower temperature than this one. So this would be our smallest one, and then next would be number 2. After that, we've got 7 and 10. That's easier to order. 7 would come next, and then here the 10 is our largest number, so problem number 4 would come last. So our order from least to greatest would be number 3, number 2, number 1, number 4. This one here, we were practicing a lot of things. The main focus of this was integers or math with positive and negative numbers, but we also got an opportunity to practice some decimals in this problem. I'll go ahead and erase all of this, and we will move on to our next question. Okay. And this next one is focusing on some decimals and fractions. We've got the question, Cindy wants to buy a sofa and is deciding between 2 options. One sofa costs $600 and is on sale for 1/3 off of the original price. The other sofa costs $500 and is on sale for 25% off. Which sofa is cheaper? We've done one similar to this in the past. Let's see if you remember. Go ahead and try it now. All right, so in this problem, we've got 2 options. We've got option number 1 is the $600 sofa. So I'm just gonna say with a better marker, there you go. We've got sofa number 1. We know it costs $600 and we know it's on sale for 1/3 off the original price. Now 1/3 off the original price is not an amount of money, right? It's just a fraction. So they are telling me that the sale is, we're gonna subtract 1/3 of the original price. So in order to find how much money that is, I need to find what 1/3 of $600 is. Now I've written it like this for a reason. We are trying to find a fraction of a number. We learned that if you're trying to find a fraction of a number, that is multiplication. I need to do 1/3 times 600. Now, fraction multiplication was one of the things that as a class, we had some lower scores on. So I really want to practice this here. When you're talking about adding and subtracting fractions, you guys were awesome at knowing those denominators, those bottom numbers have to be the same. When it comes to multiplying fractions though, that's not true. In order to multiply those, we just need both of them to look like fractions. So that's 600, I'm going to put 600 over 1 to make it look like a fraction. And then we're going to multiply right across. So I'm going to multiply my two numerators together, which gives me 600. And then I'm going to multiply my two denominators together. So 3 times 1 gives me 3. After that, all we have to do is simplify. Now to simplify, you are looking for a common number that you can divide both of these by. One of the comments I saw on a test was something about, well, the numbers aren't even, so you can't simplify. If both numbers are even, like 2, 4, 6, 8, 10, that's a sign you can divide by 2. But even if you have an odd number like 3, it doesn't mean you can't simplify. You just have to look at other numbers. So 600 and 3, both of those numbers you can divide by 3. So I could say 600 divided by 3 gives me 200. And 3 divided by 3 gives me 1. And then the last part, 200 over 1, that's the same thing as 200. Now I've got math all over the place. What did we figure out? Remember, what we were figuring out was the sale. The sale says it's on sale for 1/3 off the original price. We found 1/3 of the original price is 200. So we figured out that that sale is $200 off. So I'm going to write that down. On sale for $200 off. That tells us this first sofa here, if it's on sale for $200 off, well, the original price is $600. I'm going to take away the sale price, and that leaves us with this first one costs a total of $400. Now we've got one other sofa to calculate. I'm gonna give myself a little space here. Sofa number 2. We see originally costs $500 and is on sale for 25% off. Sale for 25% off. So similar to over here, what we're going to need to do is figure out how much money that is. One of the mistakes I saw on our last test was people were saying, okay, it's 25% off, so you're saving $25. 25% is not the same thing as $25. If it was on sale for $25 off, it would say $25 off. 25% is a percent of this. So similar to over there, we need to figure out how much money that is. I need to find what 25% of that original cost is. So I need to find out what 25% of 500 is. In order to do that, we want to change our 25% to a decimal. In order to do that, you just write 0, point, and then whatever the percent is. So 25. And then just like over there, that of, a percentage of a number, is the same thing as multiplication. So I want to do 0.25 times 500. If you did not do that earlier, go ahead and do it now. But when you multiply that out, that's going to end up giving you 125. So what did we just figure out there? Well, 125, that's how much money it's on sale for. I'm not on sale for, sorry. That's how much money you're taking off with the sale. So we found out that original price is 500. It's on sale for 25% off, which we figured out is $125 off. So to find that total price, same as what we did over here, I'm going to take my original price, subtract the money you're saving with the sale, and that is going to give us $375. So the question, which sofa is cheaper? We've done all this math to figure out that second sofa is cheaper because it's $375 instead of $400. You know, with questions like these, I love to have you justify your answer. If I had asked you, like, explain how you know or justify your answer, one of those, I would just simply say what you figured out here. You could say for the first one, if it's on sale for 1/3 off the original price, that's $200 off, which means it costs $400. For the second sofa, if it's on sale for 25% off, that means it's $125 off, which means the final price is $375. Just kind of give like a summary of the math you had to do to figure it out. So this was our second review question. Again, I love this question because we got to review so much. We got to review fractions and multiplication of fractions, decimals and multiplying by decimals. There's a lot going on in this one. The next question is going to review perimeter and area. This is one of the most common things for students to get mixed up. I think with these, well, let's read the question first, then I'll say. For this one here, we've got Jamoke is building a pen for her chickens. She has room for an 8-foot by 16-foot pen. The first question says, if she already has 20 feet of wire for the pen, how much more wire does she need to buy? Go ahead and try this first question here now. Okay. For questions like these, what I was going to say earlier is if you start seeing measurements describing a shape or a space, you see the words length and width, you see the words perimeter and area, anything like that, my advice is just start off by drawing yourself a picture. It's going to help you visualize what they're talking about, which is going to help you visualize what you need to do to find the answer. So here we've got, she has room for an 8-foot by 16-foot pen. That's giving me the length and the width. So I'm just going to go ahead and draw myself a picture. I'm going to draw, here's her space. She's got room for a 16-foot by 8-foot pen. Now this first question says, if she has 20 feet of wire for the pen, how much more wire does she need to buy? Well, if you're thinking about making this pen, it's talking about wire for the pen, where would the wire go? Well, the wire is going to go around the pen. We are talking about how much wire she needs to go around this chicken pen. It's telling me she already has 20 feet of wire. I need to know how much total wire she's going to need. In order to do that, I'm emphasizing we're going around something. Think about what you would do. Well, you would need 16 feet for this side. You would also need 8 feet for this side. You need 16 feet for this side. And you need another 8 feet for this side. In order to find out how much total feet you need, we're just going to add all those sides up. I'm going to add 16 plus 8 plus 16 plus 8. If you're ever talking about going around something, that means you are finding perimeter. And to find perimeter, you need to add. So I'm just going to put a little note here. In order to find this, we are going to add all sides. That is how you find the perimeter. Once we do that, 16 plus 8 is 24. 16 plus 8 is 24. And if we add those up, that gives me 48, and we're using feet to measure. So I've got, she needs 48 feet to go around. Now focus in on the question. The question is saying she already has 20 feet. How much more does she need? Well, if I want to find out how much more she needs, she's already got this. So let's take it away from the total to see what's left over, what she needs to buy. So I've got my 48. I'm going to subtract 20, and it's going to leave me with 28. She still needs 28 feet of wire to go around the chicken pen. Now that was the first part of the question. The second part says, she also needs to buy hay to cover the area inside the chicken pen. How many square feet does she need to cover with hay? Go ahead and try that one now. Well, in here, there's two things I think are really important. It's literally giving you the word area, and they're also describing inside a shape. We've got perimeter is the distance around a shape. Anytime they're talking about how much space is inside something or how big a space is, you're talking about area. So we've got that same shape here, but this time instead of figuring out how much it is to go around, we are trying to figure out how much space is inside. Specifically, how many square feet is inside. In order to find area of a shape, you are always going to multiply. The formula we solve for area is area equals the length times the width. I'm going to put a little note up here. If you've got these notes, I would also write this down on your paper. That area, you're always going to be multiplying. That is going to be the space inside something. So in this problem, what I would need to do to find my area is multiply our 16 times our 8. When I go to do that, 16 times 8, well, 6 times 8 gives me 48, so I carry my 4. And then 8 times 1 is 8, plus our 4 gives me 128. So to answer the question, how many square feet does she need? She needs 128. Now when it comes to the measurement, up here we said 48 feet. Feet is a distance. Down here we're not measuring with feet. They actually say it in the problem. We are measuring with square feet. So I would say 128. You write square feet as feet, and then that little 2 there, which we learned is an exponent that we read as squared. So it says 128 feet squared, or you can also say square feet. I really want to emphasize in this problem looking to see what they're describing. If you're describing going around something, you're finding perimeter, you should be adding in those problems. If you're looking at how big something is, how much space it takes up, if you're looking at the area inside a shape, then you're finding area. And in order to find area, you're always going to be multiplying. These are two things that students tend to get mixed up a lot. So hopefully seeing them together will help you figure out which one is which. This was our question on area and perimeter. Our next question we're going to look at is the coordinate plane. We've got the first question that says, Martin plotted the point -8, 7 to the right. Do you agree with Martin? Why or why not? And the point he plotted, it's right there. So go ahead and start off by saying, do you agree with him? Make sure you answer why or why not. This is reviewing what we've learned about plotting points on our coordinate plane. When we saw this lesson, we talked about how this first number here is called your x coordinate, and the second number is called your y coordinate. We also learned on the coordinate plane, or the graph, this line right here, this horizontal number line, is your x-axis, and this vertical number line is your y-axis. So if I want to plot this point, that is going to be the point that's at -8 on our x-axis and 7 on our y-axis. If a point is at -8 on your x-axis, it means on this x-axis here, it should be over here on this side. That's where -8 is. So right away, I see this is not in the right spot because it should be over here. It should be at -8 on our x-axis. And then it should be at 7 on our y-axis. So this is my y-axis here. Notice it doesn't have all the numbers on your y-axis, but if this is 2, 4, 6, this line right here is our 7. So my point should be up here. Again, I can see it's not in the right spot. Our point, -8, 7, should be over here at -8, and then up 7, which would put it right here. I'll make it nice and big so you can see it. So what did they do? Well, this point down here, where is this point? Well, this point is at 7 on the x-axis and -8 on our y-axis. So what I notice is that he's got those numbers backwards. So to answer the question, do you agree with Martin? You definitely want to say no, because this point isn't in the right point. This point isn't in the right spot. But to be more specific why you don't agree, you can just say it's not in the right spot, but see if you can try to find exactly what the mistake he made is. It's not like he just randomly put down a point. He got these numbers backwards. So you could say something like, he switched his x and y coordinate. You could say he got the numbers in the coordinate backwards. You could say he put -8 on his y-axis instead of his x-axis. Any of those would be good. Notice all of those are using vocabulary. There's a lot of vocabulary we learned in this lesson, and I think that's one of the reasons why it was one of the lessons students struggled more with, is because it's really important you know some of those words to answer the question. To help us practice that vocab a little more, I've got the second part here, which says give the coordinates of a point in quadrant 3. Plot your points on the graph. I wrote this question specifically because it's using two words I think students got backwards on the test. Those two words are coordinate and quadrant. Coordinate is a word I was already using a lot up here. Coordinate is this. Coordinate is a pair of numbers. So I'm asking you to give the coordinates. Your answer should look something like this. It should be a pair of numbers. I'm asking you to give the coordinates of a point in quadrant 3. Quadrants were those, quad means 4. Quadrants were those 4 areas of our graph. So you need to know where quadrant 3 is and then come up with a coordinate of a point that would be in that quadrant. Go ahead and try this one. I will say, as you're looking at this, there are a ton of correct answers. There's not just one. Go ahead and try it for me. All right, so for this one, I said in order to answer this question, you need to know where quadrant 3 is. Quadrants, remember, were the 4 areas of the coordinate plane. Quadrant 1 is here, and we always used Roman numerals to represent them. I guess I was bad because I used the number 3 here. We've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we want to write the coordinates of a point in quadrant 3. I want to write the coordinates, a pair of numbers, of a point that would be in this area here. So literally any point over here could be a correct answer, which is why I said there's so many correct answers. For example, this point right here could be a possible answer. What are the coordinates of that? Remember I said your answer should be a pair of numbers. The coordinates of that would be -4, -2. So -4, -2. Another one could be over here. That would be -10, -7. -10, -7. Another one, maybe this one right here. That's -1, -1. Do you notice anything about all these points? All of those points have both numbers as negative numbers. If it's going this direction, the number on your x-axis would be negative, and then if it's going this direction, the number on your y-axis would be negative. So earlier when you tried answering this, as long as you wrote a coordinate, so something that looks like this, with 2 negative numbers, your answer would be correct. I could ask you a similar question for any of these quadrants, and it would, again, there'd be a ton of possible answers. So this was our question on coordinate plane. There is one last question on order of operations. This was one of the last lessons we learned. It was one of the 2 lessons from Unit 4. So in this one here, we've got Yolanda simplified to the expression 4 plus 3 times 2 minus 5. Her work is to the left. is her answer correct? If not, what mistake did she make? So her work is over here. The problem is right here. Then that's her work right there. Go ahead and try it. Do you agree with her? If so, explain why. If not, what mistake did she make? All right. So for this problem here, I gave you a clue that we're focusing in on order of operations. Order of operations was that lesson you learned PEMDAS for. We said anytime you are looking at a problem that has more than one operation, you want to use this to tell you the order to do it. So in this problem, we've got addition, we've got multiplication, and we've got subtraction. You can't just do it from left to right. We need to use this to help us figure out where to go. So her problem is she did it from left to right. She started by saying 4 plus 3, got her answer there. Then did 7 times 2, got her answer, and then subtracted. We can't do that. If we're using PEMDAS, the first thing you check for is there any math to do inside parentheses? There are parentheses here, but there's no math to do inside them. So we would say technically there's no parentheses. Exponents were those little numbers like squared, cubed, to the 4th power. We have no exponents in this problem. And then next would be multiplying and dividing. We do have that. So her mistake is she should have started by multiplying. She should have started by multiplying 3 times 2. Instead, she started by adding. But adding would not come until later. So to answer the question, what mistake did she make? We could say exactly that. We could say she should start by multiplying, not adding. And then if you want, you could go ahead and actually figure out what it equals. So if you start by multiplying, what does that give you? Well, 3 times 2 gives you 6. And I would just copy down my 4 and my minus 5. Next, we've got addition and subtraction. We learned that if it has both addition and subtraction, you would do the problem from left to right. So you do whichever one comes first. Here, that's our addition. So we would say 4 plus 6 gives me 10. And then 10 minus 5 gives me 5. So we could say here the correct answer is 5. That is the last review question I've got for the final. If there is a topic or a lesson that you feel really confused on that we did not look here, please reach out to me or Denise and we will do our best to help you out. Again, these questions were inspired by questions that a lot of students in the class struggled with, but that doesn't necessarily mean that something here was something you struggled with. You might have something different. So if there is something you want to review before you take that final, please reach out to me. I will happily help you out with it. Otherwise, good luck on your finals, guys. You got this. See ya. Bye.